My name is Maria Fasli, and I work for the University of Essex. This should not have appeared. And I'm delighted to be back at ITA to talk a little bit about how women can carve their careers in computer science and artificial intelligence. Anna Carolina mentioned that we have a funded project by the British Council, which involves three partners, the University of Essex, ITA, and UniFesp. And the whole idea of the project is to learn from each other, to share experiences, talk about the kind of challenges and issues that women face in progressing in careers in computer science and engineering in general, and see what kind of measures of support we can put in place across actually both the UK and Brazil to support women. So this talk today is a little bit of a mixture, trying to present to you, if you like, from science point of view, why it is interesting, why should women go into a career in computer science and artificial intelligence in particular, which is my kind of area of expertise. I will talk a little bit about my own career progression. Some of you that may have seen me present in the past may find some familiar themes because I have talked about this before, and then some final concluding note. So I want to start by essentially positioning computer science as a discipline. So as humans, we have always been keen to develop technologies to make our lives easier. So if you look at our both written and unwritten history, we have been developing tools and then later on technologies to help make our lives easier. So you look at the agricultural revolution, we have developed tools that would enable us to cultivate fields, produce more in terms of products so that we can feed populations in an easier way. And as we move perhaps to more of our recent history, we have seen inventions like the steam engine making a massive difference to the world and how we do things. And of course, you start getting involved in education. You need engineers to develop these kind of technologies, and women start making their appearance. We have seen inventions like the central combustion engine and the invention of a car making a massive difference to the world. We have seen the television making a very big difference to how people view the world and the kind of perception that they have about themselves as well as their communities and societies. And perhaps nowadays we take it for granted, but back in the 50s and 60s, first with perhaps the cinema and then with television in our homes, in people's homes, you could get a completely different appreciation of the world and what it looks like and how it is to be looking at different places. And then, of course, we get into more familiar territory for us that are in this field with the invention of personal computers and the difference that these have made to our lives, from education to entertainment, how you process Word documents, the creation of programs like Excel for spreadsheets to do these kind of operations. And we have seen technology developing with mobile phones, enabling us to keep in touch now with people across the world at the touch of a button, and keep in touch with family on almost a minute-by-minute basis. I'm sure there are colleagues in this room and others that are reporting what it is that they are doing on a daily basis back to friends and family. And perhaps this is where we're heading, towards human 4.0 or something, where we really need to question what makes us human if we are to be enhanced by some kind of processors, machines, can help us think faster, do more calculations. But then what does that do to us as autonomous human beings? So this is where we're heading. And these are really interesting times to be living in. And this is why we need a lot more people to come into science and engineering, and we need a lot more women to be joining us in making technology work better for everyone. So I want to talk to you a little bit about that. So why would you want to have, in general, a career in computer science and electronic engineering? Well, first of all, we do live in the digital age. Whatever you do, you're being surrounded by machines, you're being surrounded by computational processes, by devices. So it makes sense for us to continue to develop this technology, and the future, as I said, is ahead of us. So we really need to have the capacity to develop more in this area. Typically, careers in computer science and engineering can vary quite a lot. You can get into all sorts of different sectors. You can do a degree in computer science and you can end up being a project manager, or you can end up working in a bank, or you can end up being an academic like myself, or you can end up being a game developer or a pure software engineering. So there's a very great range of careers that not just women, but men as well can go into if you study in this area. The kind of things that we are developing nowadays, they are making a difference to the world as well as individuals. Devices like mobile phones, I don't want to repeat myself, have completely changed the way that we interact with each other as humans. But the kind of applications that we are developing, perhaps more from a research point of view at this moment in time, like, for instance, technologies to support disabled people or the elderly, can make a real difference and make lives for people much, much better. There's good earnings potential. If you look at the data about how much women and men earn in this space, they compare relatively well with other areas. So you get a career that is almost for life. Obviously, it is entirely up to you how you develop, but there's good earning potential and you can develop yourself as you see fit. There's international opportunities. There's no country in this world that would not need computer scientists, electronic engineers, data scientists, and AI experts. And this is all the rage right now. Everyone is talking about this. So you don't need to stay in your home country. You can move anywhere in the world and you can have an exciting life. It's a continuous, challenging, and evolving area. When I studied for my undergraduate degree, I was learning programming languages like Fortran and COBOL that have completely disappeared now. In fact, you can earn very good money if you know these languages, because there are legacy systems out there that nobody knows how to handle. But the area has moved so much now that you don't, in some cases, we don't even need to teach our students how to code. They can just drag and drop things into a tool and they can create new applications. So it's a constantly evolving area, and this is part of the exciting aspect of computer science and electronic engineering. You develop a lot of transferable skills here. So it's all about problem solving. It's all about working with people. Typically in these applications, you cannot work entirely on your own. You have to work as part of a team. You may have to negotiate. You need to develop your analytical thinking. Be patient when machine says no, or you get bugs and you have to address them. So there's a lot of transferable skills that you require as part of this discipline. There's a lot of creativity as well, because it is all about problem solving, and it's about sometimes addressing really challenging problems, but from a novel perspective. So if you are a creative person, this is an area that I would encourage you to consider. And even areas like games, you can use a different aspect of creativity to problem solving, which is more with design, aesthetics. So you can have a different combination of skills there. You can get a lot of job satisfaction. It's very nice when you can see things, products coming to life out of your own personal effort or as part of the effort with the team. And it can be great fun, believe it or not. I want to talk a little bit about AI and why there's perhaps more potential for a career in AI nowadays than it was 10 years ago. So artificial intelligence is not something that was developed 10 years ago. It goes back actually a long way. And as human species, if you look at different cultures and even mythology, so if you look, for instance, at Greek mythology, I come originally from Greece, we have myths about the gods or even people developing automata, developing devices, and even the gods giving life to these devices. So we have always aspired as a species to almost like recreate ourselves. So this is the basis for AI. And there's two aspects. When artificial intelligence was created as a discipline back in the 50s, and as part of a workshop that took place in Dartmouth that brought together a number of really big brains, let's say at the time, there were two key areas that they wanted to address. Understand intelligence on the one hand, because if we're trying to recreate what it is that we do as intelligent beings, we obviously need to understand how it is that we are able to act in an intelligent way, how intelligence is being generated, what happens in our brain, how decision making works, how perception operates, and how we act. And then, of course, the second part is, if you understand intelligence, can you create it or recreate it using machines, using computational technologies? But the aspiration at the time, back in the 50s, was to create this human-level intelligence. And we are now where I would call it the third coming of AI. So we are in a phase in AI where AI has come back. So what happened after AI's birth in the 1950s? There was a lot of excitement. People wanted to develop machines very quickly because they thought they could recreate human-level intelligence, and we would have robots doing all the housework in our homes, and we wouldn't have to do very much. But soon they realized that actually we don't understand our own human-level intelligence, let alone be able to recreate it. So what happened was the discipline broke down into individual sub-disciplines in an attempt to focus on very specific problems. So instead of trying to create a robot that would be able to speak, would be able to sense, would be able to perceive images, the discipline split into natural language processing to understand speech and human-level language, speech recognition, as well as image processing, because people were trying to tackle these individual-level problems. There was a lot more excitement in the late 70s and 80s with expert systems, and these were systems that were attempting to encode human-level kind of knowledge in the form of rules and data. So the system, you would give Mycin is a typical example of an expert system at the time. Mycin was created to diagnose diseases, so it had a huge database of symptoms and rules as to, if you are experiencing these symptoms, this is the kind of disease that you probably have. So you could enter symptoms, and the expert system was coming with diagnoses. The problem was you had to manually add rules or change the data in the system rather than the system being able to learn. So soon expert systems failed to essentially illustrate perhaps human-level intelligence, and they were abandoned. And then we fell into an AI winter at the time. So research agencies in particular stopped funding AI because they felt that there wasn't the prospect there to create clever or smart systems to support humans. But we have seen a big comeback now, and this is mainly down to the huge availability of data. All of us walking around with mobile devices and other devices taking photos. So there's a lot of data now for image processing, and we have been able to make progress. There has been lots of developments in computational power. So we have a lot more computational power, and memory is really cheap now. So we can have these huge data centers and we can process information. And some of the progress that we have seen is not because we have developed suddenly necessarily completely new methods. We are taking older methods that have been that were created years ago, like artificial neural networks, but we are now able to make them work, have multiple layers, and have the data to process, so that systems can learn and essentially give you a good decision. So that's why we are where we are. But when you look at artificial intelligence as a discipline, it consists of a number of areas. It's not, perhaps there's a confusion nowadays between the term AI, artificial intelligence, and machine learning, and a lot of people just take it for granted that when we refer to AI, it's just machine learning we're talking about. AI, it's so much bigger than machine learning. So we're talking about having autonomous or semi-autonomous systems that we do not intervene as humans. We're talking about systems that can take percepts, they can perceive their environment and undertake action. We're talking about reasoning. And this is something that people often forget about AI, because machine learning is going to give you a result if you give it the right data. But reasoning requires a whole different level of understanding of our own intelligence. Planning, problem solving. We want systems to be able to solve problems and learn and adapt in their environment. That's why we want learning. Social ability. We don't want systems to be on their own. We want them to be situated in environments and be able to interact with humans and other systems. Proving, theorem proving, I mean here not proving in another sense, and the ability to move and manipulate objects if you're talking about robotics. So there's quite a lot under the term AI rather than just machine learning, which for someone who's done a very theoretical PhD in the understanding of autonomous systems using properties like knowledge, beliefs, and desires, I find quite frustrating, I have to admit. So when we look at why AI is progressing and why it's really needed is because we want to have intelligent systems that are able to adapt their behavior. And the idea of AI is you have a system. The system is situated within an environment which has other systems, including humans, in it. The system gets sensory data. There is something that happens in the mind of the machine, which is typically a machine learning algorithm that learns from data, and then action is being produced, it affects the environment, and this whole cycle continues. And learning is very important because it's this process of acquiring new knowledge. A system that is unable to adapt and learn perhaps is not going to be very helpful. And I'll come back to this. And learning can take place in different ways. As children, we learn by imitating, we learn in school, we learn by heart, we learn by trial and error. So there are lots of different ways that we learn as humans, and we've been trying to create similar methods in machines, and hence why we have machine learning. But as I said, AI is more than machine learning. And from both an AI, but also from a straightforward computer science point of view, learning is really important. And there's lots of different reasons why you would want systems to learn. It may be impractical or even impossible to recreate or essentially number all the different possible scenarios that the system can find itself in. Or you may want, you have implemented the system and the environment has changed, so the system needs to change. Its goals may have to change. So there are lots of different reasons. And again, from a straightforward computer science point of view, I'm sure you will all have read horror stories of governments or organizations investing a lot of money to develop systems, like, for instance, health systems. So you spend a lot of time and effort trying to create a system that will address some user requirements, very expensive, very time-consuming. At the end of the day, you have a system, you present it to the user, you think you have understood what the user wanted, and then in the end, you have a system that doesn't really deliver what you want it to deliver. But these sort of systems and the way we have been developing so far, they are inflexible. We cannot change them easily. So wouldn't it be amazing if we were to start with some initial user requirements, create a system, but then the system was able to learn from the interaction from the users and adapt itself without the expensive process of having to re-engineer, redevelop the system. So even at the most fundamental level, we can think of the process of learning as supporting essentially system development in this way, apart from supporting human decision-making. And you may have seen this before, and this is more along the lines of what is currently being developed in and what is being called analytics, and it links directly with AI, because we have been developing different types of techniques in this space. So you have if you think of analytics or techniques, quantitative techniques, and what they can deliver as an output, as benefit, as value, you have two axes. You have the value axis, and you also have the difficulty and complexity axis. So we call descriptive analytics methods that enable us to answer questions as to what happened, and this is always in the past, and typically here you have historical data that you want to analyze and you want to identify whether you can see certain patterns. If you are then going to take it up another level, then instead of just being interested in what happened in the past, just the patterns, you want to understand why something happened. So you are now in the realm of using diagnostic analytics. So you are answering a different type of question. You still have historical data. You look at what happened, but you are also interested in the why. Why am I seeing these specific patterns? What is happening behind the scenes? If you know what happened, you understand why it happened, you can take it another level up, and you can attempt to use techniques that are called, that are under the sphere of predictive analytics that enable you to answer questions as to what may happen. So here you can do what-if scenarios and try and predict what can happen in the future. And a typical example here could be a company, for instance, that is interested in understanding whether one of its products could be adopted by customers. So you look originally at the historical data, consumption of different products. You're trying to understand why people behave in that way. And then in predictive analytics, you try to predict whether a new product with a certain set of characteristics will be adopted by the customers. And there's another level which is even further up, which is, okay, if we are able to predict the future in some way, which anyone tells you they can do it with 99% probability, is just not going to happen. There's prescriptive analytics. And here we've got very tailor-made methods that we can use. But remember, in predictive analytics, we have what-if scenarios. Here in prescriptive analytics, we are attempting to do something in addition to the what-if scenarios. So these are about techniques that attempt to influence behavior. So still in the example of a company trying to understand whether a product would be adopted, what should the company do to influence the behavior of the consumer so that they can definitely buy the product? What kind of marketing campaign, what is it that they need to put in place? And this very often makes more sense in policy decisions, where you have governments, for instance, that want to implement a new policy, and they are interested in understanding what is it that I need to put in place in order to make actually the citizens follow policy X. So there are all sorts of applications, but the further up you go up in this axis, you go from information to optimization. But if you look at the other axis, the horizontal axis, the further up you go, the more complex these techniques are, the more domain-specific they are, and you cannot easily take one method from one domain that applied to one problem and put it in another one. So it becomes more complex, but you get a lot more value, because if you are able to influence customers, if you are able to influence citizens, or you can understand what can go wrong, this is really, really valuable. So you go from hindsight to insight, and then foresight in terms of the knowledge that you can extract and how valuable these methods are. And I'm going to go through this slide quickly. So from my own personal perspective, if you like, as an academic and researcher, and the kind of work that we are doing, we are looking at data. So we want to have historical data. And, if we have historical data, then we can understand what happened in the past, and we can inform action and strategy, especially when we work with companies. So we are doing descriptive analytics on this front. When we start thinking about why we're seeing certain patterns, we formulate hypotheses and a theory that we are then, as part of the next stage, we're going to try and understand whether it works, how accurate it is. So we are now in diagnostic analytics. In this space, we can start developing really complex models with artificial intelligence, and we can have what they're called multi-agent systems, where you can essentially recreate whole societies, artificial societies or scenarios of specific problems, but in a simulation world. And you can implement your theory and try to answer questions and what-if scenarios. And here you can have really complex models attempting to understand what is happening in a real-world environment. And then if you are able to simulate, then you can have the data from the real life and be able to compare it against the data from an artificial simulated world that you have created, and you can try and compare and see, what it is that you see in the simulated world. Does it match? Is your theory of what you have developed within the simulated world, does it match? How closely it matches what happens in real life? Because that gives you this predictive power. And then, of course, then you have more, you have a better understanding of the kind of actions and strategy that you can take. And this is where you are in this predictive, prescriptive analytics side. And in the last few years, because of all of this that has been happening in AI, we have just seen a massive rise, both in the papers, the amount of money that has been thrown in AI. And I've got a couple of diagrams here, and you can see the top level one illustrates how many more papers in the last 10 years have been published in AI. The bottom one is the number of papers in machine learning and reinforcement learning. So in this space that we have been able to make progress, because we have now a lot of data that we can use for learning and for testing. So we have seen a lot of effort going in. In fact, we have seen so much effort that is simply unbelievable. You remember I talked about an AI winter that we have gone through in this area in late 80s and throughout the 90s. Now, in fact, you have governments that have invested and have developed AI strategies. So Brazil has one. This slide shows, and there may be more countries now. This is the latest one that I was able to obtain. This shows, so the countries in green, if you're not colorblind, are countries that have developed a specific AI strategy. Brazil has one, the UK has one. The UK government keeps talking about how AI can support decision-making, how it can support policy-making in both central and local government. And you can see Chancellor Merkel, ex-Chancellor Merkel of Germany, playing there with a robot. So there's a lot riding on AI. This is how I would describe it. And it's almost becoming like an arms race now. Who's going to throw in the most money in AI? Which is going to be the country that is going to develop the smartest of systems? And these smart systems can be in all sorts of different domains, including for, unfortunately, war applications, weaponry. And it can be... there can be good uses of AI, but also uses of AI that are not perhaps so beneficial to the human race. And what perhaps we have not come to terms yet as a discipline and as society is that these AI or data science based systems, these systems that are meant to be smart and supporting our decision making, they do not operate in isolation. They're very different to perhaps earlier systems that we have developed within computer science and engineering that were just manipulating some data and they were giving you an outcome, because these systems that we are creating, they are using data from individuals, communities, society, groups, and they are affecting, they can affect. You can have autonomous systems making decisions on insurance policy and whether you will be provided with insurance based on data that you may have no control over. And so these systems are designed by us, so inherently they have some of our biases, the data can be biased, and there are all sorts of challenges. So although a lot is riding in AI, we still have a lot of challenges that we do not have and questions that we do not have the answer to. So it's very important to think about the kind of technologies that we are developing, but putting humans at the heart of it, rather than just pretend that we are creating a system and it's going to work wonderfully and there aren't going to be any problems, because we have seen applications of AI that have marginalized groups. They are taking their own decision because they're based on biased data that nobody has bothered to check properly. So there are lots of things that we need to make sure that are addressed in the future. But we have made a lot of progress, right? We are talking about driverless cars. We're talking about systems being embedded in financial markets and making decisions rightly or wrongly. We're talking about lots of big multinational, international businesses and corporations making use of AI for all sorts of things. Not necessarily the most clever of AI, because if you go onto Amazon and you look for a product, it doesn't mean that Amazon is going to give you a really good recommendation, but they are using AI behind the scenes. And I hope I can play this video. We've done amazing things, and things that I don't think, 10, 15 years ago, we would have considered possible. So in robotics, for instance, robots have been created that have amazing movement. Look at this robot. I mean, it could go to the Olympics, as far as I'm concerned. I wouldn't be able to do what it's doing. So it's incredible. But do you think you would be able to drop this robot in a swimming pool and it would learn how to swim? What do you think it would happen? Just to see if you're paying attention, really. Do you think it's going to learn to swim? It's going to get to the bottom. It's not going to start moving its arms in any way. Why? Because it has been programmed to deal with very specific tasks. So it cannot learn being thrown into a new environment. But you take a baby which crawls, you throw it into a swimming pool, it will start swimming magically. I mean, there has been research. Don't try this at home, by the way. But it's a simple example to illustrate that so far we have made some progress, but we are nowhere near the kind of initial idealistic notion of AI at the level of human level intelligence. So the kind of Terminator scenarios that we are seeing in sci-fi that are influencing our perception of AI, they are nowhere near around the corner, because the systems that we have been able to develop, they can give us good decisions, provided we have given them really good data. But you cannot take an algorithm that gives you amazing results from one domain, put it into another, and give you equally amazing results, because it depends on the data, it depends on different parameters, features. So we don't have that. And we have made almost no progress at all on systems that are able to reason, or very little. The progress has been in machine learning mainly, which is not a bad thing, but we need to put this into context. There's a lot more work that we need to do in AI. So I want to move now to the second part of the talk. I hope I have excited you from the point of view of this being really a cool area to be working, because there's still a lot of things that we have not been able to solve, and we need creative people to come into this, including women. But being a woman, it's not always easy to carve your career in this kind of domain, because as Anna very eloquently illustrated, these domains can be very male dominated. So because we have stereotypes that prevail. Women are not good in science. We're not good in maths. Why would you want to go down the path of electronic engineering or computer science or mathematical sciences? And we're being switched off, unfortunately, at a very young age. There's also society's expectations of women. We are meant to be, obviously, women, but also mothers, wives, house cleaners, really important, apparently, good cooks, money earners. This has been added in the last few decades, so it's not good to be the first part. You have to be able to earn money as well, and be so much more. Be the entertainer, be always happy, always smile, always positive. So society asks a lot of us. Let me put it like that. So I'm not entirely sure you are able to fill into all of these roles. I'm certainly not. And we are not helping ourselves either. Some of you may have heard of the imposter syndrome. Have you heard of it? Yeah? Who has not heard of the imposter syndrome? The men in the room have heard of the imposter syndrome? Okay. The imposter syndrome is when you, like, I'm standing in front of you, I'm standing here thinking, why am I standing here? Why do I deserve to be in front of these people and be talking to them? What do I have to offer? And why should they be listening to me? I'm not good enough. I shouldn't be here. There are other people that could be doing a much better job. So this is the imposter syndrome. And we are guilty. I mean, I'm still guilty of it. And I wouldn't say I do it on a daily basis, but at least once a week. At least once a week. There are prejudices and discrimination that unfortunately we propagate within our societies for one reason or another. And in some cases, when you are, for instance, in academia or you're working in the private sector, if as a woman you decide to have a family, taking a maternity or a career break can be crippling. Because then you lose touch with the discipline, or you come back and your boss says to you, you know what, you were at this level before, but now when you come in, you're going to be down a couple of levels because, hey-ho, you have to start again. So there are all sorts of issues. And it depends on the country. There are cultural contexts as well. So I want to tell you a little bit about my own career and progression and how it has gone for me so far. And I'm not going to start at the point of view of, this is how I was in school, etc. I want to tell you what happened from the point of view that I got a job as a university lecturer in the current university that I am. And that was back in 2000. So don't count the years, because then you can tell how old I am, okay? So don't do that. You're not allowed. So back in 2000, when I got a job, and I was fresh out of my PhD. Honestly, I had no clue what I was doing. My funding had run out, and I thought, someone is giving me a job. I will have money to put food on the table. I will gain some experience, and then I'm going to see what I'm going to do. But I had a broad idea of how I could develop within academia at the time. So I was in a computer science department, and I had, plotting the kind of number of years that I have to work to get to the pensionable age. I thought I needed 35, 40 years. I thought, what am I going to do? So in the beginning, I'm going to build up my research. I'm going to build up my teaching. Perhaps in mid-2015 or something, or just a bit before that, I'm going to apply for promotion. I was hired as a lecturer. I don't know what's the equivalent here, associate professor. And then the next stage was assistant professor. So I thought I could be promoted in 15 years' time, maybe, from the start to assistant professor. Then I'm going to start building even more my research. Then perhaps at the age, 25 years down the line, I could apply to become a professor. In the computer science department that I was at the time, there were 2 females, if I remember right. Originally 3. One left as soon as I started, and the other one left a few months down the line. So I don't know if it was my effect of getting in, but so that's the plan that I had. And then I thought, well, maybe when I'm mature enough, about 55, 60, I can get on a professional role like a head of department or head of school, because people will trust me. By that moment in time, I will be more wise, perhaps. This is not exactly how it panned out. So in the beginning, I went through a period, there's a dark cloud there, because I thought I knew what I was doing. I love teaching, so I invested a lot of time on my students and on novel pedagogical methods. And apparently that was not valued very much by my academic department at the time. And I went through a tough time because I thought I was doing the right thing. I attempted to apply for promotion, and they slapped me back. By that time, I was the only female, and it was all males ganging up, against me, in the sense that there were a limited number of promotions. They thought I was focusing on the wrong thing, and they just wouldn't put me forward. So it took me a while, but in the end, I managed to get promotion, going against, actually, my entire academic department of all male professors, senior lecturers, and everyone else to get promoted. That was in 2007. And then I became head of school. Believe it or not, see the other head of school up there when I thought I would do it in 2035. I did it in 2009. So I had just been promoted, and I took over as head of school of, at the time, a combined school of computer science and electronic engineering of about 65 members of staff, where it was me and just one other female professor. I was not professor at the time, and then she left, so I was left on my own again. And this was for me a seminal moment. I'm not sure seminal as there is the right word here, but it was an important moment in my life, because this is what I looked like as head of school. That was years ago. I was younger, fresher, more naive. And my school, as I said, was different. My academic department, it was almost all male. We had other challenges that we needed to overcome. My colleagues, interestingly, were viewing me like this. So as if I was 3 or 4 years old. They were looking at me as if I was a little girl, and the little girl perhaps is trying to tell us what to do. Not all of them, but some of them. My husband looked at me like this, and was warning some of my colleagues that actually she may look like a little girl, but she, don't think that you're going to put her in the corner and she's going to cry. In the end, I ended up being like that. This is from Lord of the Rings, and this is the first of the trilogy, where you've got Gandalf the Grey sort of saying, you shall not pass, because in my role as head of school, I had to defend my colleagues actually in my department. So it was quite an interesting experience. And we went through an interesting journey. I can tell you all about it another time. But as I said, I was the only female. I was taking my colleagues out on a bus ride to have away days and talk about exciting things that we should be doing for education and research. And they were smiling, and they were accepting of me. And now the school is one of the biggest schools in the university. We have a lot of students, we are delivering a lot of research, so a lot of things have happened, but it took an awful lot of work. So, but that shaped me as an individual and as an academic and as a person, really, because I had to be, I was being put in situations that I had not envisaged in my normal academic career, because I had to negotiate my colleagues. I had to tell them what to do. I had some colleagues of mine that had double my experience, and I had to tell them what to do. And that's not easy when you're a woman. And you're facing sometimes quite strong resistance, not because you are telling someone to do the wrong thing, but perhaps because they cannot accept you for what you are. So we need to be sensitive to that. So then I became a professor at a much earlier age. Then I moved on from my role as head of school to take on something, a very different challenge within the university. Instead of being the head of an academic department, we founded a new institute, and it was all about putting it together, creating an identity, developing research capacity within the university. I was then awarded a UNESCO chair, so and now I'm the executive dean. So the role that I currently have is I'm on top of heads of departments in the Faculty of Science and Health. So where I thought up there in 2035 I would get one of these leadership roles, I ended up taking one far sooner than I had anticipated. And the point that I'm trying to make here is you can plan all you like, but sometimes plans don't work out. I love the minions, so I just thought I should leave you with a minion as part of this slide. And why perhaps things didn't or did work out for me. When I look back, I'm trying to think of what is making me who I am in terms of nature, how I was made in terms of my genes and the kind of attitudes that I have, versus nurture, how I was brought up as a child. And there's still an interesting question in my mind, which one of this is the strongest, if you like, influencer in the way that I am. My father family and the kind of school environment that I had as a child influenced me quite a lot. My father was someone that did not believe women should be put down, or girls shouldn't go to school or shouldn't develop themselves. He kept pushing me, encouraging me to actually go ahead and do whatever I wanted, no matter how crazy that sounded at the time. And he instilled in me 3 principles. My father is a key figure for me. He kept saying to me, just because you're a girl doesn't mean you cannot do things, so just go for it. It doesn't mean that a man can do it better than you. In fact, you can do it a lot better than some men at times. The second one was, if you want something, you don't just wait for it, you go for it, you ask for it. Because unless you ask, you're not going to get. How are people going to know? And the third one was, because of the family situation that we were in, the only way to get out of poverty, do something with myself, was education. So for me, going through education, and I still believe very passionately in education, and opening up education to everyone is the key to make lift people from poverty. And my view of the world is quite interesting, even to this current day and the kind of job that I have, and sometimes the kind of challenges that I face and the things that I have to do. I don't look at, someone says to me, oh, we have a problem, the world is about to end. And I'm thinking, no, the world is not about to end, it's a challenge. As a computer scientist, how do I deal with it? I look at it, I break it down to its individual components, I solve individual bits and pieces, and then I synthesize it. And there's no need to panic. And that has helped me quite a lot. And I think and there's some Greek there for those that know Greek or are interested in learning Greek. And I think there's some interesting messages from my own career that I would like to share with you. So I think in Greek, we have a saying about children that they are like unwritten books. So a child is, that's why the picture there, there's nothing almost written in it. It's down to us as parents, individuals, society, school, to shape them. So what we tell children really matters. Had I been told, oh, Maria, surely you are not going to be good at maths or problem solving, I think I would have ended up very different. So parents, family, schools and educators. In the UK, we have a big problem. Girls are being switched off science and mathematics and engineering from a really young age. And we have to do something about it. You have to create sometimes the opportunities, but equally, if an opportunity comes to you, you have to grab it when it comes to you, because you don't know if it's going to come around. And sometimes, us as women, we think, oh, is this the right time to be doing X or Y or Z? I'm not entirely sure there will ever be a good time to be doing X, Y, or Z. And you can have a rewarding career, whether you plan it or not. Things can happen to you, and you need to be flexible. And one of the things that we are doing, we're trying in the UK, and it's more of an effort now at the international level, is to try and support women with different types of careers and make sure that we harness their creative power. As I said, we really need women and men in computer science and electronic engineering. So there's my colleague Anna, who will be presenting later this afternoon, will be talking about Athena Swan, which is a framework that has been created to support women. And this is how we're being funded as part of the British Council. But it's important that we, and I say we because we are all collectively in this together. We need role models. We need women that can tell other women, you can do it. Don't be afraid. You can go into science, engineering. You can become an academic, or you can become a CEO. Or you can do whatever you want in life, but we also need supporting mechanisms and processes, and we need to raise awareness, because I'm not here standing up accusing men of not enabling women. Sometimes we don't raise awareness with our male colleagues of the kind of challenges that we face. So we need to be working together on this rather than trying things out on our own. As I said, Anna is going to talk about Athena Swan later today. And some final thoughts. I think what I have learned is to dare and challenge myself. If you had told me when I started at my academic career in 2000 that I would be where I am today, I would have laughed out loud at you, and I would have said, no way. But I dared myself, and it worked. It could have been that it didn't work out, but again, you need to accept failure as a learning mechanism rather than let it get you down, because, as part of learning, we learn from our successes, but also from our failures. For me, it's important to remain authentic, no matter what you do, no matter what role you've got. You have to be yourself. If you pretend to be someone else, then people are going to be able to read through you. And as Oscar Wilde says, be yourself, everyone else is already taken. And I'm going to stop here and thank you for your attention.